Hello everyone, and good morning, good afternoon, or good evening, depending on where you're watching from. I hope that you, your families and loved ones are all safe and well in these difficult times. My name is Robert Scott. I'm a member of the Flight Operations Group of the Royal Aeronautical Society, and I'm pleased to be the chair of this webinar today. Before I get into the details of the webinar, I'd like to give you some housekeeping information. Today's webinar is being recorded in both audio and visual, and will be available for all attendees to access 2 days after the event. We strongly invite your comments and questions today. You'll find a question tab in the GoToWebinar platform box on your screen. If you have a question during the presentation, please submit it via the question box on your screen, and we'll answer as many questions as we can at the end of the presentation. Please note, though, that we may not be able to answer all the questions, but we'll do our best. If your question is directed to a particular speaker, please indicate to whom the question is directed. All attendees have their microphones muted, so if you wish to communicate with us, please do so via the question tab. And finally, as many of you know, we were obliged to postpone our March conference due to the coronavirus this year. However, I'm pleased to tell you that it's been rescheduled for the 6th and 7th of April next year, when we hope to see you there. Please keep an eye open for emails on the subject and on the Society webpage for further updates. Now to the webinar itself. The presentation will be approximately 40 minutes, followed by 15 minutes of Q&A, and we intend to finish promptly at 1900 UK time. Our speaker today is Air Commodore Di Whittingham. Since 2012, Di has been Chief Executive, UK Flight Safety Committee, and he is active in a wide range of industry bodies, including the Flight Safety Foundation's European Advisory Committee, EASA's Commercial Air Transport Collaborative Analysis Group, and he's also Vice Chair of the Air Transport Advisory Board. Di's two panelists today are Captain Terry Buckland and Captain Peter Terry. Both Peter and Terry have extensive experience as pilots of large public transport aircraft with major airlines, specifically in pilot training and management. All three of our panelists are members of the Flight Operations Group of the Royal Aeronautical Society, and their full biographies can be viewed on the Society's website. Today, our panel will be reviewing the accident that occurred to a Boeing 777 aircraft in Dubai on the 3rd of August 2016, during an attempted go-round. On board were 282 passengers, 2 flight crew, and 16 cabin crew. As the aircraft slid along the runway, the number 2, right, engine separated from the wing, and there was an intense fuel fire in that area, as well as fire to the number 1, left engine. After the aircraft came to a stop, the commander ordered the evacuation, but because of high winds and the external fire, there were several issues with the evacuation. The GCAA Final Report will be used to frame a discussion on some of the key findings, lessons, and recommendations that can be taken away from this accident. There is no intent to apportion blame, but merely to see what we can learn by studying this accident. And with that, I'll hand you over to Di for his presentation. Di?
Thanks very much, Bob. Well, hello, everybody. Thank you for turning up in such large numbers. As Bob has said, we're looking at this 777 accident at Dubai and the final report, which was released earlier this year. And just to remind you, they are personal opinions. They're not Royal Aeronautical Society opinions, and as was stated at the start, there is in no way any implied or direct criticism of organisations or people involved in this. That's not what we're about. And I'd also like you to think about the fact that we are viewing this with pretty good hindsight. This accident started, or at least the causal chain was only about 5 to 7 seconds long. We've had much longer to think about it than those poor guys did. So with that, we're going to have a quick look at what went on. I'm going to look briefly at the evacuation, and then we'll talk about the human factors involved and the training that went around that, and then some of the lessons to take away. Bearing in mind that out of this final report came 40 separate safety recommendations, which went to the operator, to the manufacturer, to the regulator, to ICAO, to the FAA, and to the air traffic services in Dubai. So pretty much lessons all round. Okay, so manual approach to Dubai runway 12 left with a tailwind, albeit in limits, but still a tailwind, and an outside air temperature of +49 and a concrete temperature of +68. So the pilot flying recognized the touchdown would be outside the touchdown zone, and he commenced a normal go-around by selecting toga. The thrust didn't increase during the go-around, and there was a gear-up runway contact, and was, as mentioned, a post-crash fire, which was escaped by all 300 POV, but sadly there was a fatality amongst the fire crew, and we'll look at that a bit later. So let's just discuss the events before arrival at the runway then. There was a moderate wind shear warning on the ATIS, which was discussed by the crew, and this was an update to the briefing they'd given themselves for the approach about an hour before their arrival. And the wind shear warning did include the fact, or the discussion around it included the fact that there may be a need to do a wind shear toga. The times you can see in red on the left are UTC, so it would have been midday-ish in Dubai. So vectored for the RNAV on 12 left, VREF calculated RIA 30 + 5 at 152 knots, so 147 knot VREF. And shortly before they arrived, 2 aircraft went around. They were not advised of this, and then just before they landed, 2 company 777s landed ahead of them. So there's nothing to suggest to them at this stage that there's anything unusual, although I think as everybody who's operated into Dubai will know, it is well known for the variable nature of its wind, shall we say. So 0836, they were stable, they're cleared to land, and they've got a surface wind of 340 at 11 knots. So within limits, but still not ideal. They come down the approach, the autopilot's out, the flight directors are on, and the auto throttle was in speed mode. And at coming through 750 feet, the FDR for the first time records a genuine tailwind. And the approach continues quite normally. So 450 knots, sorry, beg your pardon, 450 rad alt and 156 knots. Minimums automated call out, and the captain announced he would be landing. Pilot monitoring called at 200 feet or thereabouts 16 knots of tailwind, and then a little while after reducing to 13, so now well within limits, and 157 knots IAS. So the IAS is creeping up a bit, and as you would expect, the auto throttle start to retard. And they arrive at the threshold 54 feet on the rad alt and 159 knots. So the speed has picked up just a little bit there. One of the functions, I gather, of the auto throttle, which responds to overspeeds more slowly than it does to underspeeds. Flare starts at about 40 feet, slightly high. They're 100 meters into the runway. 25 feet RA, passing 300 meters, 158 knots, so still roughly the same speed. And at that stage, as designed, the auto throttle goes into idle mode, enunciated on the FMA, and both of the thrust levers start to come back towards idle. Now, the times at this stage that you'll see there in red are from the flare. So about 8 seconds, 2 foot, and 165 knots. So the speed has increased, and the captain says thermals, which was a reflection of the amount of updraft he was getting from the runway. 10 seconds in, the right main landing gear untilt switch is made. So they're 1,090 meters down the runway. The untilt reflects the the fact that the main landing gear trucks are tilted up by 13 degrees, and obviously as they transition into the ground mode, the switch is made. There is also a weight on wheels system which works on the undercarriage main beam. And at 13 seconds after the flare, the pilot flying decided that he was going to be long, so he called the go around, and at about the same time the automated system enunciated long landing, an automated call out, set by the operator at 67%, so pretty classic, 2/3 of the runway distance remaining, which was 3,600 feet landing distance available, so a good long runway ahead of them. 15 seconds in, he calls flap 20, which the PM acknowledges. They're now down to 153 knots. A few seconds later on, the pilot monitoring calls positive climb. They're now down to 147 knots, going through 47 feet on the way up. Pilot flying calls gear up. They're now down to 145 knots, but they're still quite low. And at this stage, air traffic weigh in with, here is your call sign, continue straight, climb to 4,000 feet. So they've just cleared the runway when this call comes in. A few seconds later, pilot monitoring calls gear up. They're now down to 135 knots, 77 feet on the radalt. He then acknowledges the clearance, which is what you would do, and sets the missed approach altitude in the MCP, and they're by this stage down to 131 knots. So almost 10 knots below VREF. And at 25 seconds, they peak at 85 feet, and then the descent starts. 3 seconds later, the pilot flying has recognized what's happening, calls wind shear toga, and selects full thrust, but sadly, it is too late. So the runway impact, just 30 seconds after the flare, 31 seconds after the flare, at 124 knots, so still above stall speed, but and under control, but with the undercarriage retracting, and the aircraft then sort of settled onto its belly, and as Bob said, the right engine separated as it slid for about 800 meters, about 30 seconds ride down the runway before it came to a halt. And now we get into the evacuation phase. So there is a fire going outside, and this is a quote from the report. So 1 minute after the aircraft came to stop, the evacuation was triggered. And during that time, they'd spent a while trying to locate their emergency checklist, which had been flying around the inside of the cockpit. But in this period, there were a load of passengers who got out of their seats to try and get stuff out of the overhead bins, and they blocked the aisles and the passengers to the exits. So the cabin crew are now busy trying to control these people, and I should say now, the cabin crew performed magnificently throughout this episode. They did a great job in very difficult circumstances. And as you could expect, it was the first time for them too. So there's a photograph still taken from a video inside that aircraft on that day. So not only were people getting their luggage out of the overheads, but they were also stopping to take video, even though the aircraft was very clearly on fire. And you can see there, I think, in the background, the haze as the smoke starts to enter the cabin. So a little bit more complex now. This evacuation is actually a case study in its own right. It is worth reading to take the time to do that. So 90 seconds after the impact, the fire commander and the first two fire vehicles arrive on scene. That's a pretty good response in anybody's language. But it is 90 seconds in, and at 6 minutes 40 from impact, all the occupants are clear except for the captain and the senior crew member, who are still inside at 9 minutes 40 when the wing explodes. What were they doing? Well, they were looking for a young lady who had been separated from her family at some stage during the evacuation process. And they were forced forwards by the smoke and flames and ended up jumping from the door onto L1, which had detached and was lying on the ground near the aircraft. The box below the writing there shows you which slides were in play at what stage. So bearing in mind the evacuation is starting 1 minute after the aircraft has stopped moving, and you will see there the light green bars are showing that there were just 4 slides running for much of the time, and in fact R1, as you can see there, was only active for a very short time before contact with a piece of airport signage actually tore through the slide and deflated it. And also there on the R4 level, you'll see there's a gap in the middle where the fire service actually managed to fill that with firefighting media, which stopped the evacuation from there. 85% of the people in this evacuation left through the back of the aircraft. As you can see there, just through a few of the slides. It was a very complicated procedure, and it was actually, comparatively speaking, reasonably benign, although there was a fire. And there's the 90 seconds mark from the time of the evacuation. So that's the certification standard, the 25.803 certification standard for an evacuation. And as you can see there, there was no way they made that. So a problem perhaps to think about with the way certification testing is done, but the point to take away is that all the passengers and crew got out of the aircraft. A couple of pictures here, you can see the detonation starting there on the wing, the right-hand wing, fuel fire led in the right wheel bay, which took a great chunk of upper wing skin panel off, and that sadly is what killed the member of the fire service. The other minor injuries on the RFS side were all heat injuries because of the concrete temperature. So 4 serious, including a couple of fairly thorough spinal injuries just through the impact, but everybody survived. So the question is about the evacuation. So 1 minute, a whole minute lost getting into this whole process. So the question is, should the evacuation checklist be a memory item? That's something for you to consider. And maybe we need more than one type of evacuation process. And if you go back now, think back now to the San Francisco 777, again, the flight crew who would have been very stunned by what had happened to them. The back of the aircraft's been ripped off. They pirouetted across San Francisco, and even then the captain was trying to hold ahead of any evacuation, even though that aircraft was also on fire. So people need to think about this. And the link at the bottom of the slide there is to the Flight Ops Group specialist paper on emergency evacuations. It is being updated and will be reissued soon, but it's a very good read. I commend it to you. So let's get into the human factors then. And we will start with the obvious distraction and the ATC call almost as the aircraft lifted off, changing the missed approach procedure. Now, yes, you can argue that the first officer tripped into or tripped away from aviate, navigate, communicate, but bear in mind that this will also have been a distraction for the pilot flying, who's now wondering where it is he now needs to do with his aircraft instead of letting the automated process run its course. And there were, as I said at the start, some recommendations that went to ATC about this. But missed approach procedures, generally, wherever you go in the world, those of you that have flown them will know that more often than not, as soon as you start flying it, you're asked to do something different compared with that which is programmed into your FMC or is in your flight plan. Something to think about for the future. And then there are the auto throttle modes, and particularly the inhibition logic for the TOGA system. And we'll look at that in a bit more detail now. So the auto throttle modes that they would have been dealing with at the time, speed mode, so as it implies, versus thrust, where it will give you what you ask it of, and then thrust reference, which will give you that which is calculated for you. So single TOGA push gives you the thrust mode, and the second push of it will give you the reference mode. So thrust to give you up to 2,000 feet per minute, thrust reference will give you most of it. And then for the toga to work, clearly you need the auto throttle armed. The aircraft needs to be in the air mode, and we'll come to that in a second. Either the glide slope engaged or the flap lever not up. Well, they had 30 flap. Thrust limit mode isn't at takeoff, they were landing, and either toga switch is pushed, which it was. The air mode is also required for the flight directors, was another cue. As I mentioned, as it came through 25 feet as designed, the FMA announced idle, and as the thrust levers came back towards idle, and the auto speed brake becomes active. Now that toga inhibition logic relies on the weight on wheels system, or both of the main landing gear truck lights truck systems untilting, those captions coming on, or being below 2 feet rad out for greater than 3 seconds. So the weight on wheel system, contact with the runway in other words, or below 2 feet rad out. As it turns out, they were in contact with the runway for about 6 seconds, with either one or both of those untilt switches having made. But bear in mind the call of thermals and the concrete temperature. You've got air boiling off that runway. They've got a low rate of descent. It's a wide body. It's known to be comfortable sitting in ground effect, and it perhaps shouldn't come as a surprise that the crew didn't physically detect the touchdown. The change in the audio, the ambient audio was apparently available or audible on the cockpit voice recorder, but clearly the crew did not pick that up. Because they didn't detect the physical touchdown, they did not detect that the aircraft was in ground mode. And it's not just the physical touchdown, of course, it's also that toga inhibit being below 2 foot. And when you are in ground mode, the speed brake handle movement, it was armed, it is the only system indication the aircraft gives you that you are on the ground. An interesting concept. There were 2 partial deployments over that 6-second period, both of them for less than 1 second. But these guys were, as their training required them to be, eyes out, looking down to the far end of the runway at the landing attitude. So they did not, either of them did not see that speed brake handle moving. The go around, we know, is a high workload area. So that automatically starts to stack the factors against you. It was the first long landing for both of these pilots. Neither of them had got into that regime before, and so there will have been an element of startle and surprise. And in fact, for both these guys, it was the first time they'd been involved in a go around close to the runway, close or on the runway. The distractions we have talked about, those were obvious. There was some expectation bias. The captain, when he pressed the toga button, clearly expected the thrust would increase. It didn't. And then the first officer's call, the pilot monitoring's call of positive climb, merely confirmed his belief that they were climbing away quite comfortably from the runway. And then we look again at another little wrinkle, the EGBWS, where the mode 7 can give you a wind shear alert for a performance increase due to increasing headwinds and severe updrafts. And you remember we were talking about the fact that their airspeed was actually increasing as they passed the flare. Now that was not enabled on this aircraft. And you might ask yourself the question about whether the operational consideration, particularly for an airport like Dubai, with all that it implies for wind shear and the like, was properly weighed against the cost, because there would have been a cost implication in fitting this to the aircraft. Now the training program for the operator was based on that Boeing provided. This is a direct lift from the report. Boeing provided FAA approved training program which did not include the toga inhibit logic at any point. So you might want to just ponder that one. And the computer-based training that the crew had done did not cover the FMA changes that you might expect if you go around after toga inhibition. So there is already a bit of a knowledge gap there. Once you've touched down in the 777, the only means you've got of increasing thrust is manual, because the auto throttle is inhibited. So you would expect to get a master caution and an auto throttle disconnect on the ECAS, but that isn't mentioned by Boeing or the operator in the EPCOM or the FCTM. Interesting. And similarly, the auto throttle would have been available when they climbed above 2 foot run out, which is also not mentioned in the EPCOM or the FCTM. So you can perhaps begin to appreciate why maybe the knowledge of the automation was not quite what it might have been. There was also, the report looked at the fact that the EPCOM and FCTM lacked a bit of guidance on go-arounds just prior to or after touchdown. And this wasn't picked up on the audit either. So the oversight system also did not do them any favors in this respect. Neither publication required monitoring or call out of the FMA changes on a go-around. And the normal procedure for go-around didn't require a call out of the thrust setting when the pilot flying selects toga, and there were silent PF and PM thrust verifications as part of that go-around process. So you're already back into that model where you can appreciate perhaps why people didn't necessarily understand fully what was going on with the aircraft, which was behaving as it was programmed to do. There was some fleet evidence, FDM evidence, of inaccurately flown go-arounds, and the operator had looked at that, had recognized it, and had worked it into its evidence-based training. An enlightened operator doing manual handling simulators as a phased program, which covered all sorts of things, not just this go-around area. But the go-around after touchdown was specifically taught, and that was done with the autopilot, the flight director, and the auto throttle off, which would be known to the pilot. And the deal then was you select toga, you note that there's no response from the system, and then you apply manually full thrust. And then the procedure follows with selecting flaps 20, rotating at VREF, and pitching towards 15 degrees. And of course, noting no response, that's fine. But in this case, the pilot flying did not knew his autopilot was off. He would not have been aware at that stage that his auto throttle was not available to him, because he thought he was still airborne. So now we come to the lessons, and the basics, I think, is you fly the aircraft and you back it up with the automatics. Interesting here that Airbus, in the development of the A350, went away from the standard type rating and instead went for a system where you learn to fly the aircraft in its raw form to start with, and then you overlay in manual form, and then you start to overlay the different automatics and layers of protection. So you actually know how your aircraft is going to respond. Possibly a learning from other accidents predated this particular one. So go around after the flare. The logical approach would seem to be hold the attitude, apply the power, stay on the ground to VREF. If you have touchdown, stay on the ground to VREF. And it is surprising how much airspeed some of these big aircraft will lose, particularly if the spoilers have deployed just between the flare and touchdown itself. Select the flaps and then hit toga as required when you've got a positive rate of climb. So that would have, I think, kept these guys out of difficulties, and the use of the toga, which of course reconfigures the flight director as well, would have allowed them to follow the guidance thereafter. Air traffic, they really do need to either stick to the published missed approach procedures and change it if it's not suitable, or if there really is a reason for changing it on the go, then they wait for a suitable moment. Give the crew time to get the aircraft climbing in some form of ship-shape fashion. Mixed standards within fleets. We talked earlier about the EGPWS system and the fact that it is possible to have differing standards, differing levels of enhancements built into some systems. It just means that people have to learn different things, and you either waste the enhancement because people have to ignore it and work to the lowest common denominator, or you confuse people. So from a fleet management perspective, I would suggest to you that it'd be a really good thing to make sure that all your aircraft were as close to the same standard as you can get them. HF incidents from the simulators. They don't seem to be reported. We don't seem to pick up the human factors wrinkles from the simulators. And I was talking earlier with people who are working on the 787 sim and others, where it is very common for pilots who've had either the auto throttle failed on them, or who've been given a problem late on where the auto throttle hasn't responded as they expect, to call a go round if it fails, or merely not to apply power on a go round and they come to grief. So why are we finding that out from simulators and not, rather why are we not finding it out from simulators, and instead we have to find it out from an accident? I suggest that that's not a good way to be working. Safety enhancements should be standard. They shouldn't be sold as an option, and you can think here of the AOA gauge on the 737 MAX, classic example. If you've got an enhancement, put it in. We talked about evacuation checklists. Should they be memory items? Should they be different? We know that there is no such thing as injury-free evacuation. Most of them are practiced with the wheels down. We never really look at the scenario where the gear is up, and maybe we should. And maybe we should be looking at the emergency evacuation where you know you've just come to a sudden stop. And last but not least is the need to give operators and crews the information that they need to understand their aircraft and its systems. You need to understand what the automatics are doing for you. You need to understand what the implications of failures mean for you. For example, sensors, AOA probes and the like. You need to understand. And we saw that with the Lion Air and Ethiopia accident, with MCAS. If you don't know a system's there, or you don't know how it functions, you are extremely poorly placed to deal with it. So here we had an accident where the crew were placed in a scenario, so this all happened over a period of about 7 seconds. As soon as the gear came up, that aircraft was no longer recoverable, even if he'd gone to full power then. And that was down to a combination of a training system which was designed with the best of intent and a lack of information that had come through with some of the manuals as they've been developed through the aircraft certification process. So human factors through and through, the aircraft performed as it was designed to do, and there will be questions, no doubt, about design philosophy, but the good news, 300 people walked away from this. The sad news, the management of the evacuation led to 1 fatality. So I'm going to stop there and pass it back to Bob, who will manage the question process. And I believe we may have a couple of comments, I think, from Peter Terry and Terry Buckland. So over to you, Bob.
Thank you, Di. Wow. As we all know, when things go wrong in an aeroplane, they tend to go wrong very quickly and very badly. And this crew, unfortunately for them, and the others involved were caught out. It does raise some very interesting points, which you've largely covered, and I'm grateful for that. I'd like to ask Terry and Peter to join us now. And I know, before we get into the questions that have been presented to us, I know that the two of you had some conversation about the startle factor in advance of this presentation, this webinar today, and I just wonder, as it appears to have been a factor in this accident, if either of you, or maybe both of you, would like to comment on that.
Right, yeah, hello, I'm the Terry, and there's Peter Terry over on the other side. Yeah, the startle effect, what a lot of people view with training and checking is it's too predictable, and that you get an engine failure at V1 on every check, and you have a engine out approach and a go around, and everyone knows the format with slight variations. But it's when you get the startle effect, as these guys, poor guys, really did seem to have, that's when you can learn a lot about yourself and about your knowledge of the aircraft. And I think startle training has already been shown to be very effective.
Great, thanks. Peter, anything to add to that?
Indeed. My focus goes a little bit with the inconsistencies between the flight crew training manual, flight crew operating manual, and SOPs. The particular focus I have is, for example, on takeoff. The pilot flying with this company has his hand on the thrust lever and will set toga or press the button below 50 knots. And when the thrust is set, the pilot monitoring will monitor that and say thrust set or some similar comment. Obviously, because the thrust being an appropriate or necessary for a safe takeoff. In the event of a go-around, however, there is no requirement in the flight crew operating manual or the flight crew training manual for the pilot flying to have his hand on the thrust levers, nor is it a requirement of the pilot monitoring to confirm verbally that thrust is set. In three former companies of mine, we had a common call out on go around, and that was check thrust. In other words, that the pilot flying will prompt the pilot monitoring to check that he has initiated the thrust, and if not, do something about it. Two of these companies, who are still in existence, had decided that because of commonality with different airplanes in their company, to go to standard Boeing. And in that process, they removed this go-around thrust check call. Now, it's interesting in Emirates that it is not, because it's not defined by Boeing, for the hand to be on the thrust levers in the event of a go-around. Training instructors were giving guidance to pilots, that's a good idea. However, the idea that the hand is on the thrust lever should also be a sort of prompt that if it doesn't move, then something's not quite right. And a call out, check thrust, might be appropriate. I do recall that this particular call out on a previous company, shortly after they had decided to go standard Boeing, they carefully reinstated the check thrust call after the flight of this particular accident in Dubai.
Thanks, Peter. Terry, you've already sort of touched a little bit on this, but I have another question here. Do you think that the old style OPC have caused a lack of training and go around other than from MDA? And what has EBT done to help to improve this, if anything?
Well, it's been happening for a while that there's been improvements in the training, perhaps not in the actual testing of pilots. That's got to be pretty well laid down with standard failures and procedures. But most companies have a second day in the simulator, a training day, where in the review of recent events, which is the evidence in EBT, a company can then practice the various maneuvers that the crews on the real world down the line might have got wrong if it is a developing trait amongst mistakes. And okay, Di correctly mentioned hindsight, and only last year at the training in the 787 simulator that I've been doing, we were practicing go-arounds from touchdown, and it was quite demanding.
Great, thanks, Terry. Now this touches on passenger behavior during evacuation, so I'm throwing it open to all four of you actually. And of course, many of you will know that the Flight Operations Group has produced an excellent document which touches on this subject, and that is passengers stopping to take baggage with them. What can we as an industry do, and what is the regulator's role in helping us affect change? And I'll throw that open to the four of you.
Shall I start?
Yes, please. Yes.
I think it's a big problem, and you see it across the industry, the passenger non-compliance with safety instructions generally. So it starts at the moment of briefing. The book says you've got to give a brief, and you know, please would you listen to the brief? And actually, I'm going to have my headphones in. I'm going to be on my laptop. I'm going to be reading a book. I'm going to be talking to the person in the row behind me. People just ignore it, and you know, there just may be the moment at which a single snippet of information means the difference between somebody surviving something and somebody not. So I think we've got a piece of work to do. We have started some of that with EASA. Not that that'll affect the Brits for very much longer, but it's to deal with the passenger awareness of safety issues, that we have to have passengers collaborate with us on the safety journey. And that means they need to understand. It's not good enough just to say, don't do it. They just need to understand why they shouldn't do it. And eventually, we're going to have to end up protecting people from themselves. We're not going to get away from bags in the cabin. We know that. That's a commercial reality. It's here to stay. But what we can do is maybe start to think about things like central locking or some other means of discouraging that sort of behavior. Because we know that people have been injured by bags during evacuations, never mind possibly lost their lives as a result. And it'll be very interesting to see what comes out of the Sheremetyevo Superjet investigation in that respect, because almost from the start of the evacuation, when you can see the whole back end of the aircraft's on fire, there are people coming out with bags. And we know you cannot leave an aircraft stopping to take a bag without taking at least some time, bearing in mind you've only got 90 seconds according to the spec.
Thanks, Di. Terry, could we give a quick little plug for our document on the subject and tell people where we are with publication of the updated version?
Yes, the evacuation of commercial aircraft, we, as Bob said earlier on, we produced in 2018. We had 3 authors. I'm one of them, but the lead author was a former CAA cabin safety manager who has led the whole process. And in light of more recent events, we decided to produce a version 2 of it, which will be on the streets, hopefully very, very soon. And it's published by the Society in collaboration with the Honourable Company of Air Pilots as well. And although you can never have everything up to date, we hopefully will have a lot of lessons learned. Why do people take their bags? It all depends what's in the bag, I suppose. But it's a really good document, and most people who have read it agree.
Thanks, Terry. I'm just sorry, I haven't gone to sleep. I'm just looking at the questions that are coming in. Airlines. Knowledge is not a separate competency under the ICAO system. It is incorporated with application of procedures. Not quite sure what that means, but what it leads me to is a question for Peter. And you were very, you mentioned several times earlier on about this business about hands-on throttles during the approach and missed approach. Do you think that had a part to play in in this accident? And if so, what's your thoughts on adopting that procedure in the cockpit?
Yes, I think it does. I also think that if Boeing have set up a set of procedures, what we commonly know as standard Boeing SOPs, and a lot of companies have adopted those on airplanes which don't have such a sophisticated auto throttle system as is on the 777 and the 787. It behoves any pilot who's flying one of these less sophisticated airplanes, but with an auto throttle system, which is a simplex system, to always have their hands on the thrust levers on the basis that they can't rely on them. And therefore, they become more familiar with action of the auto throttle and to be alert when same does not work as appropriate. I think under these circumstances, perhaps there is a sort of over-reliance because the auto throttle is engaged. They're actually trained to use the auto throttle at all times. A lot of operators on less sophisticated Boeing airplanes say if you're manually flying, then the auto throttle should be disconnected. This is not the case on this airplane because it has a different trim system, etc. However, if you're going to have a standard set of SOPs which can meet across from different types of airplanes produced by the same company, they should be competent to accept the limitations of the auto throttle system. So I would encourage hands-on thrust levers at all times, and I do, in answer to your question, consider this had an influence over this accident.
Right, thanks. Any other comments from Di or Terry on that one?
I was looking at the knowledge. Sorry, Terry, go ahead.
No, I said Di. Off we go.
Yeah. I was looking at the knowledge implications of this. You did mention that. I think it's one of the sad things about the industry and the way it's developed, and I understand why that might be, but there seems to be no incentive for people to develop really deep levels of understanding of their aircraft. They develop enough knowledge to get through the simulators, and that's because the simulators are being used for testing rather than for training. So we have a process where it's that the regulation requires people to be tested in the simulator. The question is really whether that's still appropriate in this day and age when you now have some very sophisticated FDM protocols that will allow you to look at how people are performing. Line checks always used to work before simulators. That used to be good enough. So there's a question about how you teach people about the high technical merit elements of all this, and whatever happened to common sense. So I mean, I see there is a question about when's a suitable time to retract the gear on a go around. The answer is when's a suitable time to retract the gear on a takeoff. It's not as you're just as you're clearing the runway, unless you want a nasty scraping noise. So you know, these SOPs are built up for a reason, and they drift for a reason. And the simulator is the area to practice the difficult things, to practice, to train, rather than to be tested. Personal view.
If I could just come in there, conversion course, commercial pressures are such that there's an enormous amount of training crammed into a finite amount of time, either in the classroom or the simulator. Because if the guys had really learned verbatim the flight crew training manual and the FCON, they would have seen hidden away. It actually says the toga switches are inhibited when on the ground. That's hidden in a whole chapter about the autopilot system, and you know, it's not even put in bold print. It really is hidden away, and I just think that the time pressure is something that's really bad. And on the other hand, though, some training organisations this year started sending out a lot more information before a conversion course, so the guys would have time to study the books in greater detail.
Thanks, Terry. This could be a webinar in its own right. I think this business about what's the appropriate amount of training and what isn't. If we have time, we'll go back to it briefly. Another question, perhaps Peter this time, how much did CRM help in this whole scenario, or did it fail?
Well, I think in practicality it did fail because although SOPs were followed, if one looked through the report by the GCAA, they considered there was a good rapport between the two pilots. There was a good command gradient, and there was good support until this last moment where the SOPs fell down. Now, when they fall down, according to CRM, one should pick up the other. Unfortunately, neither observed the deficiencies of either one or the other, or the automatic system. So ultimately, it fell down.
Right. So bearing in mind that we don't want to apportion blame today, what could we learn from a CRM point of view? Because it seems to me that there were two factors. One was the startle factor, and the other one perhaps was lack of technical knowledge of what was happening with the order throttle. Is anything specific CRM wise, or is it tied up with technical knowledge? Terry, this time.
Carry on.
I think you said it's either or. I think it's both. And it is all, a lot is being tied in here, like what Peter was saying earlier on about calling out the FMAs and being aware of what the aeroplane is doing and not letting the aeroplane fly you, but you fly it. And as Di said, back to basics. It's a combination of all these sort of things, really.
Right. Thanks very much. I've got an answer to a question here, so I'll read the question first. I wonder why Boeing stopped putting the evacuation checklist on the control column. Apparently the answer is it removed the evacuation checklist because it was out of date and we couldn't keep it current. So that's from one of our TAME experts who's watching. And please, can you indicate how an operator could achieve a common fleet? Financial implications, evolution of aircraft built, manufacturer driven? Not quite sure what's intended with that one. Can anybody?
I think that refers to my my comment about trying to maintain some form of commonality, and clearly you can't, with different standards of engine and so on, cover all the bases. But with major systems, you really ought to try to standardize. And yes, there are financial implications, but do you want to lose an aircraft or damage an aircraft because crew X didn't know that a warning was available, or ignored a warning because they didn't understand it? It is that sort of process. You know, there is a training element in there, there is a cost element in there, and we're talking an ideal world. But if you can, you should avoid too much of a divergence in the various standards of aircraft, because you know, given what we've been talking about with technical knowledge anyway, you just add to the problem.
Right. Okay, this is this sort of off the top of my head question for everybody, and that is, we have an enviable safety record in our industry. We're very proud of it, and it showed a steep decline in the 60s and 70s, and to a lesser extent in the 80s. Now it seems to have sort of plateaued, if you like. Would anybody like to suggest why that's happened and why we might improve it further? Or have we reached a stage where it's never going to get any better? Terry, first of all.
I don't really know. It can always improve. But a lot of it really goes back to what Di was saying about not really understanding the more complex systems of the aeroplane. I mean, quite honestly, the Asiana accident on the west coast of America was 3 years before the Dubai one, and the causes, although the actual accident was different, the causes were very similar. The crew didn't understand the complexity of the 777's automatic flight control system. And that's a quote from the NTSB in 2013. things move very quickly these days. So there was 3 years for people to have learnt about some of the foibles of the 777 and 787 now, automatics, and nothing was disseminated, or if it was, lessons weren't learned. So there are always ways that we can improve things. I just think, going back to what was mentioned earlier on, that some of the training, things are just glossed over a little bit because there's not enough time.
Thanks, Terry. And as your 777 man, this is another another Boeing question. Just a quickie: is the toga inhibition feature fitted in any other Boeing aircraft?
787. Peter's flown the 76 and 75 and 73. I haven't for a long time, so Peter might know.
Okay, Peter.
I'm more recent to the 73, and the 73 has a delay mechanism. I don't remember now how many seconds. Is it 6 seconds? And then it would disconnect, but then you get a flashing warning light saying the autothrottle's disconnect, a red light flashing. The 76 and 75 was a long time ago, and I think probably I'm as up to date as Terry is.
Okay,
Yeah.
we have a 747 pilot sitting underneath the table who you can't see at the moment, and he says the 747 has got the same system as the 777.
Oh yes, okay, I got that one. Thanks. Thank you. Moving on. I think this one's for you, Di. Thank you for the thorough presentation. What could the airport have done differently to improve the emergency response?
The emergency response was quite difficult, and I think that the main issue turned out to be problems with controlling it, and the fact that they never really switched into a defensive mode once they'd started to get rid of the passengers. So that they managed to block the flow from one of the slides just through the physical positioning of a vehicle. They managed to stop one of the slides with filling it full of foam at one point. So there was a bit of lack of coordination, perhaps. And then of course, maybe a failure to tackle the seat of the fire because they didn't use all the techniques that were available to them. So the firefighting approach never really changed from the moment they arrived at the scene of the accident. So could they have backed off and let the aircraft burn out? Well, probably yes, but when that wing blew, of course, they'd still got 2 people searching, so there were issues there with numbers, with counts of who was doing what. So it was a very difficult scenario, and as is always the case, and you know, we rely on the RFFS guys to get in and do things for us, and they do so very bravely. No communication on this instance between the fire service and the crew. There could have been, certainly when the fire crew arrived, which should have been, you are on fire, you need to get this done al pronto. But easy to be wise after the event. But I know there have been changes in training, there have been changes in response, and for example, the typical fire training at most airports involves a mock-up of an aircraft that's on its wheels, and yet we frequently see evacuations which are more difficult when the undercarriage has failed as it's designed to do, or is up, as was on this occasion. So.
Thank you. I've got time for one more question, and then I'm going to go around the panel for your closing remarks. So first of all, thank you to everybody for attending today and for your questions. And I hope you're going to stay in touch with us because we are planning more webinars in the future. So the final question for Peter and Terry, it's with regard to simulator checks. How often do you see the gear raised on takeoff too early?
Quite the reverse. It's often left down in the simulator. People forget. Very rare. I've never seen it anyway. Have you, Peter?
No, I haven't. I was going to say exactly the same as you. It's more likely to be left down. I have seen often with an engine failure a rotation before they got to VR. They hear a bang and think, oh, I must get airborne. I've seen that often, but the gear being raised early, no, normally left down.
Okay, thank you. I'm going to make a quick closing remark and then I'm going to hand it over to you, gentlemen. Just a reminder to all that an email to the recording and a survey will be sent out in 2 days' time. Please do let us have your feedback. Thanks to our speaker and panelists for their interesting analysis of the accident. And once again, please make a note that we were holding our next Aircraft Commander Conference on the 6th and 7th of April next year. And thanks again for joining us. So I'll hand it over first of all to Terry for your closing remarks, sir.
One of the jobs I have to do, I'm chairman of the Flight Operations Group in the Royal Aeronautical Society. And we do lots of, apart from the evacuation paper, we have other papers that come out that you could find of interest. And we're always looking for new members to come and join the Flight Operations Group. And when we don't have this dreadful virus, we have regular meetings in London and we have people from all over the world. So I would ask if you were thinking that this was good and I really enjoyed it, that perhaps come and join us. Thank you.
Thanks, Terry. Peter?
I would heartily endorse that. We have had over the years members, and still do have members from overseas who come on a regular basis to our meetings, which are roughly, 5 or 6 times a year. And we encourage that. Some do come from Canada, America, et al., Greece, and so on, who come on a regular basis. So do not, if you think that distance is a problem, put that at the back of your mind. You have the opportunity to travel. You're very welcome.
Thank you both. And finally, but certainly not least, Di.
Thank you, Bob. Just to remind people, this is an operator that was doing its best, that was using evidence, that was investing in additional training, and still ended up backed into a corner where they lost an aircraft despite their best endeavors. And it's so often the case, you don't find a hole in your system until you have an accident and a thorough investigation. And the question, I think, to the industry is that maybe we ought to start looking more deeply, maybe into the practice accident concept, but really start to drill into where these human failings might be precipitated by factors beyond the control of the people on the spot. So they were doing their best.
Thank you, Di. Wise words indeed. And once again, everybody, thank you very much for joining us today. And we look forward to your company sometime in the future. Thank you.